What's up, guys? I wanted to make a quick video on how to put a Fourier series into Desmos because I think Desmos is awesome for visualization. I use it a lot, all the time. But if you don't care about that, then I'll just put a timestamp in the description for when we are looking at the final result. So anyways, if you're putting in a Fourier series, that is a sum, and you can actually just find the sum here, or you can just actually type in sum, and then it pops up, and then we're going to go from 1 to, it should be infinity, but infinity doesn't work on Desmos. We're just going to start out at like 5. Now, let's just start typing in what we got. So we got, 2 over n times pi. And then in parentheses 1 minus cosine of n pi over 2. Cool. And so that was our an term. Now you want to put in the sine term, which is sine kx, but remember that k is just n pi over l times x. Now, this l is something that we can choose. So we can choose any number for it to be. So I'm going to add it in as a slider. Next we want the cosine term. So cosine would be omega times t. But remember, omega is just n pi over L times v. That's the relation we get from the wave equation. And then times time. Now, v is going to be a separate thing that we can add, that we can choose. T is time. It's a separate variable, so we're going to have to add it in as a slider. And we do want it to start at 0. Personally, I don't want to go backwards in time, so I'm actually going to put on this side of the slider, or like on this side of the domain, a 0. So this does the bounds of the slider. So now I can go from 0 to 10 is the default. I could even make this like 100, and I can go all the way from 0 to 100. Anyways, the last thing that I want to do is, this is a bit messy because it goes on forever, but we are only looking at this function where the string is. So we want to add some bounds to it. So the way that you add bounds is you use these curly brackets, and I'm just going to put from 0 for x to L. And so now we can see that this is that. So that doesn't really look much like what we're looking for, but that's just because we're only summing up to 5 terms. Maybe if we go more to 10, that looks a lot closer. What about, I'm actually going to put this in as a separate slider, n. So this is, we're choosing up to what it's being summed to. And what you can actually do, you can actually go to this step, and we're going to put in a 1. So this means now, instead of going through like decimals, it's actually only just going from 1 to 2 to 3 to 4. And I'm going to put in some bounds really quickly. Oops. There you go. So now you can watch, as I add more of these sine terms, the approximation becomes better and better and better. And theoretically, if we went to infinity, it should be perfect. But look at that. That is exactly what we were looking for. And so we can actually increase the length of it if we want by changing this L slider. I'm going to put it at like 2. And the last thing I'm going to do is actually this t, instead of it going from 0 to 100, I'm actually going to pick this 4th option right here. And now it's just going to go continuously on forever. Those are just some fun little adjustments that I thought are handy, so I thought I'd mention them. Anyways, let's go ahead and press play on t, and we can see how it moves through time. So this is how it starts out, where we're holding the string in this weird way. But if we let go, this is what will happen. Um, and I've never seen a string oscillate like this before personally. So definitely it is very strange. But this is what should happen if we hold a string in this weird discontinuous way and it goes. And this is all according to the wave equation, which is awesome. Anyways, yeah, that's about it.